Somehow I had the assignment for intercepts due today instead of yesterday. The bonehead thing on my part, but it's fairly easy to do that. So the way you do the intercepts is very simple. Do you remember what I wrote on the board last time? Now, I really recommend you go back and copy down the exact statement that I used for the y-intercepts. I'm going to abbreviate it. But if you write out the entire statement, you will end up understanding it better. It's going to take you maybe an extra 5 minutes on the assignment to write out that statement. It'll probably cause you some sort of a psychotic episode to remember to write that statement out. Okay, and if you're that unstable, well, nobody in here seems unstable, I hope. And I'm confident in that. But seriously, it's hard to remember to use that statement. That's the issue. The 5 minutes it's going to take you an assignment to write out what it means every time you do something. Well, get in the habit of doing it. And then you're going to ask yourself, okay, what statement am I supposed to write? It'll be automatic. Now, if you haven't written down the statement, go back and flip through the video from last time. You'll be able to find it pretty quickly. So I'm going to abbreviate that statement, but I think the words and the logic of that statement, if you write it out at least half a dozen times on your initial assignment, is abbreviates it. The y-intercept occurs when x equals 0, because the y-axis is the line where x equals 0. So letting x equals 0, we get y equals -2 times 0 plus 6 equals 6. So the point 0, 6 is on the graph. So we can start drawing the graph. Go right here. Here's y, here's x. I don't advocate making marks 0 to 10 before you know what the intercepts are, before you know where the graph is. I advocate you just draw the line y equals 6 in some reasonable, at some reasonable point in the graph. Okay? So you don't want it too close to the x-axis. You don't want it too far up, but that's an important point. So you just put it there, somewhere probably closer to the end of the y-axis than to the x-axis. Okay, then x-intercept. Y equals 0. So at y equals 0, you get 0 equals -2x plus 6. And you solve it. It's a very simple linear equation. I'm not going to write out all the steps, but you should, because you want to keep reinforcing those steps until you've done about 1,000 problems, at least 100. Okay? So we get x equals 3. So the point 3, 0, because y is 0, x, when y is 0, x is 3. So you put x equals 3. Well, no reason we can't keep equal scales in this case. So if I put x equals 3 here, this distance looks like roughly half this distance. It's not necessary. It's two axes have the same scale? Sometimes it's impossible. What if y was 300x plus 60? Okay. Or 300x plus 3, even worse. Okay. We'll see what you do with that case. Anyhow, you don't have a point here. You have a point here. That's your point 0.06. And you don't have a point here. You have a point here. I sometimes see people make a point up here, and that point has nothing to do with this graph. Okay. When x is 3, y is 0. So this is a point 3, 0. So this is your y-intercept. This is your x-intercept. Then you can draw the line. Now, it's kind of hard for me to draw the line here because I don't have a good looking at the board, but there it is. Okay, so this line is the graph of y equals negative 2x plus 6, and we label it thus. Now, when you draw these graphs, do all this labeling. So you reinforce what you've got. And so somebody that's looking at it to see if you know what you're doing, like me, if I'm trying to grade a test, can see immediately that you know what you're doing. Okay? Then I can look back at your work and say, yeah, that work looks good. But I don't want to have to look back at all this to see what you can label. Do you understand what I mean? Now, actually, it'd be easy enough for me to do that. The reason I don't want to do that is because you need to have your work written out like that and show yourself that you understand it. Also, if you're trying to review, it's a lot easier to find what went on just by looking at this than it is looking at all these details. Okay? So you want to have a nice, well labeled graph. Now, if you didn't know how to do intercepts, it would have been acceptable maybe just use -2, -1, 0, 1, 2 to do a table. And well, you plug -2 in here, you're going to get 10. Plug -1, you're going to get 8. Plug 0, you're going to get 6. Plug 1, you're going to get 4. Plug 2, you're going to get 2. If you look at the pattern of these numbers, they're going down by 2 every time this number goes up by 1. Well, you got -2x here. So every time x changes by 1, y is going to change by -2 times 1. And that's exactly what the table tells you. Now we can plot these points on the graph. X equals -2. If this is x equals 3, well, then we're going to need x equals 1. And x equals 2. So let's see, when x equals 2, y equals 2. Well, if y equals 6 here, then y equals 2 is going to be down about here. And y equals 4 is going to be about here. So the point 2, 2, well, 2 here and 2 here. It's going to give us a point about there. And this is a hand-drawn graph. That point's not exactly on the line, but it's close enough that I see maybe I should have made my y equal 2 line just a little higher. And when y equals 1, when x equals 1, y equals 4, that point is right on the graph. Okay. So these 2 points lie on the graph. Now, if you did this, you wouldn't have found the x-intercept unless you went up to y equals 3. Okay? You get information about the graph a lot more quickly if you find the intercepts. It's usually the first thing you do when you're graphing anything. So we'll see lots of different graphs as we go into the intermediate algebra of the course. But it should work. Okay, so anyhow, we could label y equals 8 and y equals 10, and then x equals -2, x equals -1, and we get a point here and a point here. In other words, if you find the intercept and draw the line with reasonable accuracy, and every graph I saw had pretty good accuracy, okay, for, not just reasonable, it's pretty good. And then do a table they're going to reconcile. Okay? Make sense? All right. So that's basically it for using intercepts to graph the function. And I think it's a fairly easy assignment. Don't wait until 11:50 tonight to start it, though. Okay, since it's due by 11:59. Start it, give yourself a comfortable amount of time to do it, and let it sink in. Okay. Okay, so I've asked everybody to sketch this picture here. Okay, very simple. And then put reasonable values for x and y in. So I'm going to use values, and if you haven't got it, you can still do it as an exercise to make sure you know what you're doing. I'm going to let x equal 14 here. And let's see, if that's 14, that's 20, that's about 40. Okay, and we're going to let y equal 7 here. And if that's 7, there'd be 14, 20. Well, I say we got 20 here. So I'm going to do it with these numbers, and then you're going to do it with your own numbers. All right. Now what I want to do is I want to draw an arrow from the leftmost point, this point, arrow that goes in the horizontal direction from this point over to this line. Okay? Can everybody do that? Make yourself that horizontal arrow. It was the right direction, but you came up about 14% short. Okay. Yep. Okay, now from the tip of that arrow, draw another arrow that goes up to the second point. Should have paused the video there, but it's going to look like this. So everybody got those arrows? Okay. Now, some of you drew graphs that are big enough to label and some didn't. but I didn't warn you about that, and I didn't tell you to make this big. So I'm gonna draw those arrows out here. And I'm gonna make them a little longer than they actually, I'm just gonna kind of enlarge. Oh boy, that's a terrible straight line. I'm just gonna enlarge this picture a little bit. And I'm not gonna include the X and the Y axes. I'm just gonna include the two arrows. They're my two arrows. Now my question is, how long is this arrow? If you get that, then you can tell me how long this arrow is. And just put that number for how long this arrow is. Just put that number under the arrow and the number for how long this one is to the right. I'll pause the video for a minute. See how people are doing. Okay. So the numbers that I would put here, I'm going to put this a little bit more. Okay. So I'm going to say that here, the number I get here is going to be 26. Now I've written the word run equals 26. The run is how far we run in this direction. And the rise equals 13. Okay. Now a more complete labeling. This point has coordinates 14, 7. And this point has coordinates 40, 20. More complete labeling of the rise and run. I say run equals 40 minus 14 equals 26. And rise equals 20 minus 7 equals 13. I could have, if this triangle was, or if this graph was bigger, I could have written all that in here, but I don't have room to write the 20 minus 7 and the 40 minus 14 unless I write so small you can't see it, which I do too much of. Okay. So this is kind of a shorthand for what I really want you to write. Fair enough? Now, I'm going to draw a straight line on each picture that connects the graph. And I'll put a kind of a boundary in here. I crowded myself. Okay. Now, over here, I'm going to write what I could write here, but I'll write it over here for right now. I'm going to say slope equals, okay. Have you heard the words rise and run before? Okay. So let's just stop and see who can tell me how the slope is related to the rise and the run. Okay. Not everybody, but several people indicated that they'd heard the words rise and run before, and somehow they were related to slope. The simplest way to understand what the slope is to understand that it's the rise divided by the run. The slope equals rise divided by run, which equals, well, the rise is 13, the run is 26. Okay, so if you haven't drawn the big triangle here, or if you've got a big triangle on your graph and you've got room to put all this in, it's fine to do it on the actual set of coordinate axes. But one way or another, make sure you have a triangle with all this information labeled in the places where I've labeled it. And there's a good reason for doing it in those places, and you'll see that in a minute. But see if you can write out everything for your triangle with your numbers. Okay, now what I'm saying is not everybody is doing it exactly as I said. Somebody, for example, had everything right, but they didn't have this up here. They had it over here someplace, or maybe it was on another page. Maybe it was in a different notebook. I don't remember. Well, I'm exaggerating. But if you don't have it right here, you're not doing what I think you ought to do in order to have a good picture of what everything means. If you have to look over in some other part of the page to see where these things are, if you don't have a standard way of doing it, you're not going to understand it as quickly or as well, and you're not going to retain it as long. Okay, so slope is rise over run, which is 13 over 26. Well, you have your own numbers, and everybody pretty much had the right numbers there. Just didn't organize it quite in the way. Now, in some cases, your numbers reduce, so you reduce the lowest terms. I didn't intentionally make it this way, but I got a nice simple fraction of 1/2 here. Okay? So the slope is 1/2. Then I put 1/2 right next to the hypotenuse with a box around it so that I can look at this picture and see exactly what I did to get the rise, the run, and the slope. Okay? If you do that 3 or 4 times, you'll understand it, and you'll understand it for a long time. And even if you forget it, if you just review a little bit before a test, it'll come back to you. But you should do it enough times. It only takes 2 or 3 minutes. You should do it enough times that it's automatic and you completely understand it. All right, doesn't take that long to really master this idea. So that's how we understand the slope between 2 points. Now your book is going to give you a formula. I recommend that you don't use that formula until you've drawn the picture. Okay? But the formula is just the same as the picture. I'll show you what the formula is. The formula will work for any 2 points. So let's say this point is x1, y1, and this point is x2, y2. Then if I have my horizontal and vertical dotted lines, which help orient, they're more or less optional, but this line is x equals x1. This line is x equals x2. This line is y equals y1. And this line is y equals y2. If I'm in the habit of doing this with the numbers, it's real easy to see what to do with the symbols. Once you're in the habit of doing this, then it's easy to understand that what you do here is run equals x2 minus x1, because you're subtracting this coordinate from this, just as I would have subtracted 14 from 40, and just as you subtracted the two numbers. And the rise is y2 minus y1. The slope equals rise over run equals y2 minus y1 over x2 minus x1. I don't have room to write that out separately, but I just put a box right there. Now, the problem with the formula is people usually use it mindlessly without associating with any kind of a picture or any kind of geometry, without really understanding that this is the rise and this is the run. It's just numbers. I can identify these numbers and I can put them into this formula and I get the right answer and I get credit for that homework problem. I advise you, for your own sake, not to do that. Okay? Even though open math and the videos will probably tell you can do that. And some videos are better than others. Some videos tell you more about what it means than others. Most of them are half decent. Some of them are excellent. Some of them, I'd like to find better ones. Okay? And I think the textbook is written pretty well. If you read that, you're going to get all the same stuff and reinforce it. But don't fall into the trap just because you're in a hurry. Depends how big of a hurry you're in and how much you want those points. Okay? Homework points count, but what really counts is the tests. So when you do the homework, the goal is to prepare yourself for a quiz in class the next day and for a test coming along. Okay? All right. Well, that's pretty much what you need to know about the slope at this point. It's enough to digest in one session, okay? Now, let's just say that I have a straight line. Well, I'm just going to give you the form. It's a standard slope-intercept form of the equation of a straight line. That form, make sure this is showing up, is y equals mx plus b. Okay, the slope is m, the y-intercept is at 0b. Make sense? Maybe not completely, because you haven't seen it before. And why are we doing this? Okay, well, 0b at some point on the y-axis. So I'm going to let the slope, let the point on the y-axis be 0, -6. So there's a y-intercept of our straight line. Now just to relate this back to the slope-intercept form, let's say then we have an x-intercept of tan 0. Okay. Well, I think it's helpful to reinforce what we know, to just write a little projection line for this and one for this. Find the slope. So can you sketch this picture and then use the idea we just developed to do the slope? Now take this board here and put it someplace where you can pretty much see it. Well, that's going to be hard to do. Do it like this. I can't do it like that. Looks like I've painted myself into a corner. Okay, I'm going to come over here. If I'd had any sense, I'd have done it that way the first try. Okay. So we've got this picture and this picture. Just imitate those pictures and show me what you got. Okay, now there's some mistakes being made out there. Okay, and they're pretty easy mistakes to make. Okay, how far is it from here to here? Well, first we want to do this arrow. How far is it? Well, it helps if you notice that the y-axis is here, and that's x equals 0. So now I can write run equals 10 minus 0. It's the run is from 0 to 10. And of course, you know, if you know that's x equals 0 and that's x equals 10, you know the run is 10. But I want you to write out the subtraction because you usually have to do that if you got different numbers. You got a 0 here, well, it's pretty obvious once you think about it, but the run is 10. And then here, you got the rise. Equals what? Well, let's just note that this is the line where y equals 0. And I wrote y equals 6 here, and it's obviously negative 6. Okay? So we're going from y equals negative 6 up to y equals 0, right? And that means we're going to do 0 minus negative 6, because to find out how to get from here to here, we're going to have to move. Well, we get the change in position by subtracting where we start from where we end. And we've talked about that before, but you want to get used to that idea. So the rise is 6. Now the slope equals rise over run. Write out every word. If you write out every word a couple of times, then they're going to come automatically to you. Slope equals rise over run equals, well, 6 over 10, which reduces to 3/5. So I put a big box around 3/5 and I make sure that's sitting there on the hypotenuse on this line. And now I can see at a glance every detail of how I calculated the slope. Now, I'm just doing exactly what I did before. The only little twist here is, since you got x equals 0, a lot of people are using -6. Well, -6 has nothing to do with how far it is from here to here. -6 has to do with the vertical direction, right? Okay, so anyhow, now we now know the equation of this line. So I can extend this line on forever. What's the equation? I told you the equation is y equals mx plus b. And I've told you that m is the slope and b is the y-coordinate of the point at which the graph intersects the y-axis. In other words, the y-intercept. Okay, there it is. So can you write the equation of the line? I'm going to give you just 30 seconds to do that. You might want to digest what I said, so I'll give you maybe a minute. Just want to see how many people can write the equation. Okay, some of you have it, some of you are going to have it. I just didn't give you enough time. And some of you did something reasonable that you don't want to do, even though you did everything else right. Okay. What do we know about this line? Well, now we know m is the slope, that's 3/5. Maybe write the word slope in parentheses. And b equals, well, y-intercept's at 0, b. We have the point 0, -6, b must be -6. Now, do you know what x is? Well, x could be any number from -infinity to infinity. And so could y. But x and y are related by the equation I'm going to write down. So we don't plug in numbers for x and y. Okay? If we want to write the equation, we don't, we need a y and an x. So y equals 3/5 x plus b, which is plus -6, and then plus -6 is a little clumsy. That just comes out as a -6. So we have y equals 3/5 x minus 6. Makes sense? Okay, well, that's the slope-intercept form. Now, open math is going to tell you a lot more. I've concentrated on really understanding and labeling what the slope is. And I recommend every slope you find on this assignment, you label yourself a triangle so you know what the slope means. Then do it with the symbols too, y2 minus y1 over x2 minus x1. And you'll get the same thing. Okay, but get the picture first. And then use the formula so you have both a picture and a formula. All right. Okay, now let's say I'm going to get to do a little algebra. Let's say that we want to get a line through let's just call this the point 4,2. So line through the point 4,2. This slope of 3. Okay. Well, We know the equation can be written y equals mx plus b. We know from what we're given that m equals 3, as the slope is 3. So the equation is y equals 3x plus b, which I'll put up here. We don't yet know what b is, but once we know what b is, we have the equation. Once we have the equation, then for any x, you can find the value of y, and for any y, you can solve an equation to find x. We still haven't used the fact that the point 4,2 is on the line. So we plug x equals 4, y equals 2, into the equation y equals mx plus b. Okay? Now, just real quickly, don't take a lot of time to write down the words that I've written here, but if you don't have them written down by the time you leave, be sure you go back to the video and get them down. I want you to understand those words and I want you to use them. Okay? You can abbreviate it a little bit, but understand the logic of the thought here, because you understand the logic of what we're doing, you're going to remember it more than you remember if I see this, I ought to do that. If I see this, I ought to do that. Okay? You'll understand why you're doing it, so you don't have to rely on doing it 1,000 times, so you always get it right. So quickly, and I said into the equation y equals mx plus b. Our equation now is y equals 3x plus b because we used the fact that the slope is 3. Okay? So basically, we've used the fact that the slope is 3, so instead of y equals mx plus b, we write y equals 3x plus b. Plug in 2 for y and 4 for x. Just go ahead and do that. I'm not going to come around and look. Okay, unfortunately, we're too short of time for me to give you any more time to do that, but it should be quick. We got y equals 3x plus b and x equals 4 and y equals 2. Okay? Well, if y is 2, we're going to write 2. And if x is 4, we're going to put a 4 where x is. So 3x becomes 3 times 4 plus b. You can solve that for b. So you got 2 equals 12 plus b. Well, so that b is 2 minus 12, which is negative 10. Now we've been through solving linear equations, and that's a really simple one. But write out the steps to keep refreshing, because I'm not asking you to solve a lot of linear equations now. Okay, write out the steps so you keep refreshing the rules in the steps. Well, now, the equation is y equals 3x plus negative 12, or y equals 3x minus 12. And it's not 12, it's 10. I just checked that in my head and realized it was wrong. Okay. Now we check this. Now there are a bunch of words there. We plug x equals 4 in, we get y equals 2, which we better get because we said that point is on the graph, right? X is 4, y has to be 2. So we can complete graphing this, and we come down here to y equals negative 10, and this isn't very well drawn to scale. I didn't leave myself room now, I didn't even hit my y-intercept. But you understand that we could draw the y-intercept and draw a line that goes through the y-intercept, I missed it, and through this point, okay? And if we have a reasonably well-scaled graph, it's going to represent this function. Okay, well, that's it for today. You'll have an assignment due tonight, one due Saturday, and one due on Monday. That delves a little deeper into this stuff. You should be in good shape to understand what open math is telling you.